Okay, everybody, it's about 3 minutes past the hour, so I think I'll get started as I see other people are still logging in to the webinar, but we'll go ahead and start today. And hopefully you're somewhere other than the eastern seaboard where we just got a bunch of snow. We're based here in the Boston metro area at SSH Communication Security. So today's webinar is called Encryption, the Next Advanced Cyber Weapon. And today we're going to go over how secure shell is used, encryption as a double-edged sword, current state analysis, weaponizing secure shell, does it really happen, and solutions to the problem. So first, how secure shell is used. Secure shell is used to log into remote systems and replace telnet. Secure shell is used for secure file transfer to replace insecure FTP. Secure command execution on a remote host. Secure backup and copy, secure tunneling, and existing unsecured TCP applications, and application proxy and VPN. So many of us know this already as we use this all the time in our day-to-day lives, either through interactive usage or through machine-to-machine communications. What many people don't realize, though, is that encryption can be a double-edged sword. It can be used for both good and for evil, if you will. Uses for good, just some of them, obviously, it prevents a man-in-the-middle attack. It's the preferred tool for remote administrators and secures point-to-point communications. It also secures automated machine-to-machine communications. Used for bad, and this is mostly if it isn't properly managed, it can allow malicious insiders to access critical information assets, allows lost or stolen secure shell keys to compromise an identity, and when unmonitored, blind security ops and forensics teams, and allowing attackers to thwart firewall and other policy restrictions. So if we look at a current state analysis of why we're here, what we're looking at, what we're seeing in the environment, secure shell and encrypted environments, we can see there's limited to no secure shell access controls in most environments. So most organizations are unable to account for users, don't know who has access to what information, no centralized control over key creation, and they're unable to identify trust relationships. They also have a lack of key removal and rotation capabilities, and they can't standardize on key size and type. So all of this together leads to a very dangerous situation when you're not able to actually centrally control your identities inside of your environment, especially when they have a high level of administrative privilege like they do oftentimes with encrypted and secure shell networks. There's also a lack of security intelligence in encrypted channels, so security ops and forensics teams are often blinded by encryption. They're often unable to monitor and inspect content transmitted across encrypted networks, unable to prevent data loss on encrypted networks, and they don't know which user was compromised or which user engaged in malicious activities when encrypted networks are used. They're also blind to where information is taken from or to, and many times encrypted networks and monitoring of those networks are not integrated into your security intelligence architecture, including your SIEM solutions, your DLP, IDS, and so forth. So this really leaves a big blind spot inside of the organization where other traffic is monitored and things at the endpoint are monitored. Oftentimes the encrypted channels themselves are left unmonitored, and this creates a risk point. Another thing to look at, too, is machine-to-machine communications as an identity. 20% of identities inside of an environment oftentimes are interactive users. We can control this with email monitoring, password vaults, jump hosts, human-centric identity access management solutions, security intelligence solutions that are out there. But below the surface, 80% of identities are really not monitored in many cases. In one customer example, that customer has over 1 million key-based authentications per day, with the vast majority from machine-to-machine communications. That's a tremendous amount of authentications per business day. And prior to us engaging with them, those were not monitored or managed. So you can imagine the amount of risk that was found inside the environment. In fact, I'll show you a case study in a little bit that will show the full extent of the risk that the customer was facing. Overall, most organizations lack sufficient access controls for continuous monitoring, DLP, or forensics capabilities in these M2M networks, And that's a real risk point as well. As I said, there's no centralized identity management activity monitoring solution for most of these identities. So machine to machine is a huge component of, and a hidden component below the surface of your overall secure shell or encrypted networks. And it's a need that really isn't fully addressed. And if we're looking a little bit deeper dive here in description into M2M identities, in many cases, M2M authentications vastly outnumber interactive authentications, as I used the data point before of 1 million authentications per business day. M2M connections can be hijacked by interactive users, so they're often ignored by, or not at least monitored by security operations teams, overall security teams, because they're thinking, well, these are just machines contacting one another. There's no need to monitor these machines because they're not going to be able to engage in malicious activity on their own. Although, we could think that, well, it's an M2M connection using secure shell, that can still be hijacked by the interactive user or either a malicious insider or external bad actor. And why would they want to do this? Well, because these M2M connections, because it's an encrypted channel, you're obviously trying to protect something. These often carry high-value payloads such as credit card numbers and other personally identifiable information. And as I said, M2M encrypted communications are rarely monitored in many environments. So this can create a real risk. And obviously, unless you've got some type of monitoring solution in place, which we'll talk about a little bit later, there is no monitoring within the network. You'd have to catch everything at the endpoint. So weaponizing secure shell. So this is kind of what we're here to talk about today. How is this done? And I'll go through first the sort of the basics. You've got an identity inside the environment. This could be an internal bad actor or external bad actor who's compromised in an internal identity. If they are able to access a machine-to-machine environment, authorized keys or other methods of authentication, they can get into the information assets. And then using encryption, they can then exfiltrate that information out of the organization, leaving you with little idea about what they did, what they took, and where they took it to. So this can create a huge risk, and obviously if this can be successfully executed, can allow an attacker to pull out vast amounts of information and really highly critical information, and of course leave very little trace as to what they've done. So step one overall, gain access. There are several methods an attacker can use to gain access to the secure shell environment. It could be a compromised username and password, which would be typically an interactive user obviously having to input that information. How would they get a hold of it? Password theft, social engineering, brute force, of course, an internal malicious insider also would already have access to their own username and passwords. Compromised key and passphrase, that also would be an interactive user, lost or stolen key. They could get it that way or with social engineering as well. And again, compromised key for interactive or M2M users, they could obtain this through a lost or stolen key or social engineering. So those are the three main methods we have of authenticating into the secure shell environment. And mainly, they could go a brute force attack. We've seen that with IBM's X-Force from back a few years ago, where there was a pretty tremendous spike in the number of brute force attacks on secure shell environments. Those are public-facing ports. And we're now seeing also more and more, and I'll go through this in the webinar a little bit later, more highly sophisticated attacks targeting secure shell, targeting that environment, targeting the keys, and also targeting those keys because they know that that's where both the critical information is, and also that it will provide the encrypted channel to exfiltrate that data. So let's go over a little bit what keys are. Keys are stored in a simple text file located in a directory on the client and server machine. An asymmetric public and private key pair grants access and establishes a secure connection. So there you can see basically what it would look like. Potentially a private identity key and a public authorized key. That matching key pair is basically keys to the castle. What do the secure shell keys do? Well, as I said, they grant access to the systems where key pairs match. They also are tied to a user, but without proper management controls, the actual user can be nearly impossible to determine. And based upon configuration, key usage can be configured to restrict what commands can be used and establish a whitelist of machines that can use a particular key. So let's go through a few attack vectors here that we've seen either in action or the potential for these to be utilized against an organization. And this is working with some of the largest banks, financial institution, retailers in the world. Attack vector number one is exploiting development keys in production environments. So insiders can easily exploit poor key management controls to gain access to production environments, HA and backup servers. Most organizations, and this is pretty much true across the board of organizations that we see, at some level there is, this is what they think that they have, production servers only being accessed by business users and test environment by developers. In reality, though, because the keys aren't managed, they're getting pushed from the test environment to production, and the potential for access is quite great. In fact, we have one customer that failed a Monetary Authority of Singapore audit based upon this, and it's a top 10 global bank. And then that sort of opened up the rabbit hole of finding all the other key management issues that they've had, and now they're in a multi-year remediation project. So this is a real risk inside the environment. Had an insider gotten a hold of one of these keys, they could have gone directly into production, and they could have done whatever they wanted and basically blinded the security ops forensics and their security intelligence architecture, which they did have in place with encryption. Attack vector number two, circumventing the jump host. So some folks working in IT are aware of going into an encrypted environment. You need to go log into a jump host first, and then from there you can gain access to the servers. And this allows the interactive user to be monitored while they're accessing the infrastructure. In this case here, the user is logged in to the jump host, goes into the jump host, he accesses the Unix servers in this case, it could be Linux, Windows, whatever it is, and then the user uploads a public key to those servers. He then can log out of the jump host that's intended to monitor his activities and make sure that he's within compliance. Once he logs out and he's already deployed that public key, in all subsequent logins, the user can bypass the jump host and internal security controls using the SSH key, because now he has direct unfettered access directly into the environment by going around the jump host. We've actually seen this in place where organizations think that they have their secure shell monitored, but in reality what they find is there's these backdoors that exist throughout their environment. And this is also true amongst the mainframe. So mainframe is still utilized heavily because it's considered the most secure workhorse you can utilize. But the same problem there exists, and the user can log in to the mainframe via RACF, and then the user accesses the servers and uploads the public key to the IBM mainframe. After that, subsequent logins from here, the user can bypass the RACF authentication via an SSH key and copy the credentials throughout the mainframe Unix system. So that gives them access to a much broader swath of the environment. So this is a risk that many mainframe folks don't know about. I'm sure in your organization, if you're using the mainframe, it's good to bring this up as well to say, hey, there's a backdoor here around RACF. Attack vector number four, lost or stolen SSH keys, granting a high level of administrative privilege. So one key that seemingly gives access to just one server, if it's a high level of administrative access, it actually provides access to a wide swath of the environment. And sometimes these keys have been in place for years and years and years, so you don't know how many keys you have in your environment in many cases unless you're able to monitor them. We do have a risk assessor tool that I will go over a little bit later that will help you determine where your keys are and the status of your SSH environment. But in this case, in this attack vector, if someone were able to gain access just to this one server with a compromised key, lost or stolen key, they're able to access the entire environment either using transitive trust or just going from machine to machine collecting those keys. Now remember when I showed you the keys earlier in the presentation, it was just a text file. So it's fairly easy for someone to go in, find the text file, take that text file and start using that key throughout the environment to gain access to different areas of the environment. Step two, of course, in this process of weaponizing secure shell, this is, there's different components to the weapon here. That secure shell is a way to gain access and to exfiltrate. In this case, once you've gained access, you can move on to step two as a malicious bad actor. And you can deploy a malware such as viruses, trojans, worms, rootkits. You can install backdoors and bypass authentication. Or you could do damage, physical damage or data damage, destruction to the environment through whatever kind of payload that you're deploying. And step three, of course, would be to exfiltrate that data, to use the encrypted tunnel to steal the data and exfiltrate it back to the hacker's server, blind security ops as to what has been taken and by whom, make it difficult for forensics teams to do an investigation, and slow down remediation and response activities. So that's sort of the perfect storm and the perfect attack using secure shell or encrypted channels in order to gain access, deploy malware or do damage inside the environment, and then exit the environment with the data that you want without leaving any trace. Now, to summarize these attack vectors, and there's other attack vectors that are out there as well, but mainly they all follow the same kind of approach of compromising the SSH key, creating the encrypted tunnel, and then exfiltrating everything out. If we look at each attack vector discussed, each involves sloppy key management, poor key management, no key management, and the failure to monitor the encrypted communications. In our experience, almost every enterprise we've consulted with has an access control problem, or one or more of these attack vectors is a major risk factor. And most organizations do not have the ability to capture security intelligence or forensics data if an exploit were to occur in their encrypted environment. So this can create some real issues, and I'm going to go into some case studies and actual real-world events here in a second that can show this to you. We've also had IDC, there's an IDC report out, you can get it from our website, that actually is third-party validation of the existence and the extent of the problem. Again, that's available at ssh.com. Now, the question is, does it really happen, or are we just talking about the theoretical? So, no, it actually has really happened, and we don't know the extent of everything that happened in this first case here, or the Edward Snowden case, where an attack vector, still fully unknown, however, was disclosed by high-level statements, high-level person being the U.S. National Security Agency Director Keith Alexander, who told the House Permanent Select Committee on Intelligence that Snowden was able to gain access to NSA files that he should not have had access to by fabricating digital keys. Now, we're not sure if that's secure shell keys or if that's some other method of authentication or some other type of encrypted environment. However, what we do know is that it's very likely as an administrator that they would be operating within a Linux Unix environment, and that's obviously a potential there. And we have actually seen confirmed cases before we know that it was a secure shell that was used as the attack method by a malicious insider. A former HostGator employee used an SSH key to gain unfettered access to 2,700 servers, potentially putting thousands of their customers' websites at risk. This obviously, too, is a cloud security issue where we don't know, we're putting things in the cloud, we don't know what the administrators on the other end, the third party, are, if they're doing malicious things to our data or not. In this case of HostGator, there was someone actually doing malicious things. In the case of Edward Snowden, no matter where you fall on the political spectrum of agreeing with what he did or not, I think everyone can agree that if this was your organization that was exploited like this, that would be a bad thing from a security standpoint based upon your responsibilities. And we'll leave to the history books of determining if this is a good thing or not within the government space. But still, these are very serious issues, and these are exploits that have happened and can continue to happen, and are real risks that our customers come to us, and we're actually helping to provide solutions for them. External threats, accessing critical systems. So we've seen FreeBSD and Apache both suffer similar attacks where the access was gained. They were able to contain the spread. They noticed it and pulled these offline, so there wasn't a significant issue. But if you imagine downloading these very popular software that everyone uses across their systems, and that happens, oh, by the way, it has a virus that's been deployed in it, or Trojan, and you downloaded it thinking that it was a trusted source and it's been compromised through an SSH key, wow, that could cause some very, very significant problems for your organization. So these are things that have happened in the past 2 or 3 years, just accessing critical systems, but they didn't get the full deployment of the malicious software in there, and we were able to stop it. The compromised organization was able to stop it in time and remediate. Looking at external threats, targeted advanced malware attacks. So I'm showing you some examples of malicious insiders who've done some things they shouldn't probably do or shouldn't have access to be able to do it. And then external bad actors who just got in to the front door. But what we're really, really worried about is when someone gains access and they're really targeting your organization with an advanced malware attack. Sometimes we call these advanced persistent threats. In this case, Symantec was doing some research for a large hosting provider, and they found something called Focrator that targets the Linux operating system and is capable of stealing login credentials from secure shell connections. So this is kind of interesting because it's specifically targeting secure shell connections. And why? Because we talked about this before. They know that what's traveling across the encrypted networks are really important, really confidential, really valuable information, and it can gain access to a wide swath of the environment. So with Focrator, attacks could have accessed the encryption key that secured the unnamed organization's internal communications. And this is directly from Symantec. Ultimately, the malware could allow an attacker to execute commands of their choosing and even collect data from individual SSH connections, like the connecting host name, IP address, port, and SSH key used to authenticate users. So this is a very targeted, very advanced attack that actually did get into this hosting provider's network. We don't have much more information on that at this point, but we'll keep an eye on this and for other similar type attacks, similar types of malware that are being developed out there. And of course, if you're looking at, I'm bringing this up because PCI, and of course the recent Target attack, external threats and attacking point-of-sale environments. Back in 2011, Visa issues a security alert saying that remote access vulnerabilities are the most frequent attack method used by intruders. So basically, insecure remote access continues to be the most frequent attack method used by intruders to gain access to the merchant's point-of-sale environment. So this is very important because most people are using either visual GUIs or they're using command line to go ahead and get inside the point-of-sale devices to access them and do maintenance and so forth. Oftentimes, these aren't very well monitored, and that can be a big issue. There are a variety of remote access solutions available. Obviously, your SSH Telnet to visually driven packages. And remote management applications come with an inherent level of risk, and this is from Visa, creating a virtual backdoor for unauthorized access. So once you opened up that port, once someone can gain access to that point of sale device, they then have access to possibly the network, and they have access to whatever information is inside of that point of sale terminal. That's why it's really important for these applications to be configured in a manner that complies with payment card industry standards. And while the standards in 2011 were a little bit different than what they are today, I have a slide here I'll show you in a second that shows that PCI is actually specifically addressing secure shell authentication management controls, encryption, encrypted channel monitoring, and then PCI version 3. So that's now something that organizations are all going to have to comply with. And the exploitation of improperly configured remote management software tools is the method of attack most frequently used by hackers against POC payment systems. So that's directly from Visa. It's 2011, not a lot has changed there. We know that with Target, we're looking at potential point of POS environment that was compromised. How are they exfiltrating that data? How do they take so much out? It'll be interesting to see, but a very clever way to do it would be to use an encrypted channel to pull that information out and exfiltrate that from the environment and do so without being noticed for quite a period of time. So let's look at some real-world examples. This is not an organization that got hacked, but this is an organization that came to us after having a major audit finding, and they were told to fix it. So when we go into the environment and we look at this top 5 global bank, there's a case study, by the way, on the website that goes specifically into this particular example. They have over 15,000 hosts on their environment, 20,000 plus SSH user accounts, 1.5 million keys, and they thought they had nowhere near as that many. And they had no idea they had 150,000 keys that were unknown and had a high level of privilege. So this was quite striking for the bank. It was quite striking for us to find as well, to see how the proliferation of SSH keys and the lack of access controls, how much risk there is. Couple that with the fact that they are not able to monitor these environments because they don't have monitoring in place on the encrypted channel. There's a real risk inside the bank, potentially an existential risk, which is why this got bumped up to a high priority project within the entire organization. And what were some of the results when we do the risk assessment? We look at this real world example. What were some of the risks of even doing the project? Well, business continuity risk. The bank couldn't just delete the keys or they would risk shutting down their business processes. So first, the bank had to map the trust relationships which connect their dev, UAT, and production and disaster recovery systems. Had we evaluated privileged accounts? Had we evaluated external business partner connections? All of those things had to be evaluated, mapped, and do a full discovery project there. Security risks, obviously the bank did not have controls in place to prevent individual system administrators or even non-privileged users from adding permanent credentials or SSH keys to their account. They couldn't prevent privileged users' accounts from creating backdoors by adding authorized keys, as I showed you in some of those attack vector examples. We found those, all three of those at this particular customer site, the now customer. And by the way, they're also using OpenSSH, so we interoperate with both. So they became a new customer after being an OpenSSH customer for quite some time, or a user. Also, the bank did not have controls in place to restrict what commands can be executed by user or machine. There are obvious compliance risks with a failed audit. They failed the Monetary Authority of Singapore audit. They failed to comply with their internal security controls related to security access by allowing unmanaged keys to create the backdoor to the production environment and circumvent their jump host. And they're also at risk of failing a SOX audit because they couldn't shut off access to folks when they shouldn't have access to certain areas of the environment. And they're also at risk of running afoul of other financial regulations. So there were a lot of different compliance bodies that ultimately got involved in this. A lot of different organizations around the world who they now are watching this because it became such an issue for the organization. So let's look a little bit at compliance standards too, because we know compliance sometimes trails security. And we can see the risks that are out there, but we can see that compliance is now caught up to, at least initially, the security risks that are out there, and these compliance standards are getting more and more stringent and more specific to secure shell and encrypted environments. So looking at Monetary Authority of Singapore, they've already got very strong compliance mandates in place. A lot of people think, well, it's Singapore. If you're in a bank, large financial institution, especially in EMEA and APAC, Singapore is a place, a major hub of business. NIST, FSMA, any government organizations, and also contractors who are doing business with the government come under this. Oftentimes, NIST is a best practice to follow anyway, so we're expecting an update to include specific requirements around SSH key authentication that will impact 853. PCI, access control requirements, were extended to secure shell and other methods of authentication or other encrypted channels. We've got a great video on our website. If you come to ssh.com, it's actually right now on the homepage banner, and you can actually look at the video, and it can actually, Jonathan Lewis, our Director of Product Marketing, does a really good explanation of PCI and the implications for those who are using secure shell in their environments, as well as keys, overall encryption, and monitoring. SOX, as we talked about, access control requirements, DS 5.8, NERC, FERC, HIPAA. There's a lot of requirements that are general that say you must be able to control access. And if you're using secure shell and it's not managed, you're not able to control access and you're running afoul of that. But those are obviously getting more and more specific. Obviously now, compliance with trailing security, we know there's a security issue out there. We know there's malware that's targeting different organizations. It's very advanced and could pose a huge security risk to your overall organization. And a growing awareness of the problem too. So if you type in SSH keys or SSH key management into Google, you'll find all kinds of stories on this because it's been fairly widely covered over the past year and a half, 2 years. It's really the next step in identity access management to get these under control. So if you are in identity access management, security operations, wherever you're at in the organization, take a look at this, give you some good validation of the challenges that are out there in regards to access controls in secure shell environments. And solutions. So briefly now, I'd like to go through solutions that we can provide. Basically, our platform is a centralized secure shell management solution. We obviously offer the client-server products, as you know, that offer extended capabilities beyond what you would get in open source, but also in a supported environment. So, or a supported delivery method and use method, so that you can always call in if you have a question. You have access to new downloads, and also being able to leverage all the different ideas from all of our different customers as far as development goes. In our overall platform, we have configuration management, host key management, deployment management, user key management, access controls, auditing, automation, and authentication. So today I'm mostly going to cover just a portion as far as solutions of what we do. And as I said before briefly, we also support SSH, OpenSSH, and also when you're talking about encrypted channel monitoring, any type of SSH, I believe, will function and be monitored. If you're talking about our key management solution, we support both SSH and OpenSSH, and we're extending that out to other solutions as well so that you can use that across the entire enterprise. So let's talk about how we solve the problem. So Here you've got a 7-step approach from problem scope, discovery, lockdown, remediation, management, continuous monitoring, and then network-based privileged access control. That gets you basically green-lighted, saying that you now have complete access management and governance over your secure shell environment, and that includes from the point of an identity actually accessing your environment and to all the things that they're doing while they're in your network. So number one, problem scope. This is an easy one for everybody to do. There's a free download available at ssh.com/SRA. SRA reports known and unknown trust relations, key age and key strength, private keys older than 2 years, SSH server known vulnerabilities, SSH client and server versions, number of duplicate private keys not passphrase protected, number of root key authorizations, total number of host keys, private and public user keys. So a very helpful report to see how you're measuring up. I'm sure people have some guesses as to what's going on in their environment, but this will really help to put some data behind that, to talk to senior management and other folks in the organization about some of the issues that you're feeling that you sensed you have, but now you've got documentation about this. So problem scope, again, ssh.com, SRA, download the tool. Let us know if you need any help with that. Discovery, so this is getting more into the process after you've discovered the problem with SRA and scoped it out. Now you can discover with our key manager all existing trust relationships and determine who has access to what. This requires discovering all user keys that are authorized for login, or authorized keys, and all private keys or identity keys. This must be done for all users on all servers and correctly also desktops in order to capture the entire environment and map all trust relationships. We want to lock down the environment. So once we've discovered our environment, we want to lock it down so that through a centralized process, all key setups and other key operations are controlled by root and under the control of the key manager. So that way no one is able to go in and create new trust relationships on their own. The environment's locked down and fully controlled by the key manager. That eliminates also having a bunch of admins in the organization having high-level access to deploy those keys. So this is a really critical point, and the whole idea is to make sure that only a central authority is able to create those trust relationships and grant access. Remediation, so now we've got lockdown in place, no more problems the fire can't get any larger. Now we want to remediate the problem. So we want to determine which keys are actually used and where the keys are used from one or multiple sources. And we also want to remove any orphan keys or keys that are no longer in use, needed, wanted, etc. This is going to now reduce that number of keys. As I said in the example of the top 5 bank, 1.5 million keys. Now they're starting to reduce that key count down to only the keys that they need, all without breaking the business processes, which actually is a considerable, something that you have to really work at and be good at. And we have experience with that because we worked the largest key remediation projects, SSH key remediation projects in the world. And then we want to bring the environment under management. So we're kind of doing some of these things kind of simultaneously, but we'll eliminate the manual work, human errors, save costs with automated key creation and key removals. We'll reduce the number of administrators who need to have access control privileges, and we'll rotate every authorized key and corresponding identity keys to the time limit. And this will reduce the risk posed by compromised or copied keys. Obviously, the same way we do with the password, where we require users to renew that password or create a new password from time to time and also enforce the strength of that password. We do this for the normal interactive users. I have to do it on my machine when I log in every so often. We should probably do that in our encrypted networks that handle our credit card data in such high volumes as well. And then control, where each key can be used from, and what commands can be executed using the key. We want to apply some continuous monitoring to our environment. So we want to detect unauthorized key operations occurring outside the key manager, i.e. Key setup for a root user. We want to generate alerts about key-related activities, and we want to enforce SSH software versions and configurations. And then finally, we want to have network-based privileged access control. So this is our crypto auditor solution, where we utilize encrypted channel monitoring to continuously monitor all SSH, SFTP, and RDP traffic. This will enable DLP and security intelligence solutions on throughout your encrypted network, your secure shell environment, SFTP and RDP as well, as I said, and really eliminate that blind spot from your security operations and forensics teams. Now this plays nice with DLP with an ICAP feed and also your security intelligence architectures or solutions out of the box. Privileged access controls in addition to the access controls that you've got with Key Manager as far as being able to access those servers in your environment, you'll also have a centralized authorization based on Active Directory or Radius. You can control what subchannels are available via SSH, i.e. stop port forwarding or prevent unauthorized VPN connections. This is a common way of tech-savvy folks to get around internal firewall rules and so forth. And you can also restrict destinations. Also, you'll get a forensics vault in case an exploit does occur. So if an exploit does occur, you can go back and you actually can search through what identity is done and then actually see what that, for visual depiction, you can actually see what the identity has done inside the environment. So there you can do forensics that will stand up in court or actually show you what's happened in the environment if it were a case where someone did use encrypted channels to infiltrate and exfiltrate data. And this is just a little map of network-based controls. So key management, I think we kind of understand that component. Network-based controls and kind of understanding why this is important. You want to control access, that's really critical. But you also want to make sure that your entire organization is covered. Doing it at the network level, this gives you a huge advantage because you've got coverage if you're using cloud environments and things coming through the cloud. You're able to manage remote administrators. And you're also able to manage BYOD devices, your iPad, iPhone. There's apps for that now as well as for other computers, work-at-home folks. So all those things can be monitored. Without that, people have to log in through a jump host to do this. This works in an inline fashion. You don't have to do that, have everyone logged in. So it's a big savings on time and training. Some of the advantages of that are you get 4S administration, SIM integration, DLP integration, as we talked about before, and also vaulting that information. And then you're going to protect your information assets, not just from the standpoint of access control, which is critical, but this actually applies a second layer of control, especially in the extended enterprise and in the cloud environment where you may not have employees working for you. You want to make sure you can monitor what they're doing. This is actually a product that towards the end of the year here has really caught on as some of the recent breaches have occurred where people want to gain access and visibility into this part of their environment. So success proves need. So what have we been doing for the past 2 years? So since 2011, we've been developing this key management solution and crypto auditor solutions to complement what we've been doing with our client server and encryption technology. And of course, we make that interoperable with OpenSSH and other versions, other software that delivers and utilizes SSH. But where success proves need, we've got a top 5 global bank, as I've talked about, with 2.5 trillion in assets that selected Universal SSH Key Manager, as well as our key remediation services to help resolve secure shell access controls, initially across their 10K host environment. Now that's expanded up to a little bit larger, 15K environment. One of the largest rail transportation logistics companies is in the process of deploying UKM. Their critical need was to meet critical infrastructure standards and improve business operations. So there's also benefits to beyond security and compliance. We've got some business operations benefits, and this is also seen with the Washington Post, which is one of the nation's largest media companies. They have fully developed UKM in their environment, and their critical need was to get a handle on cumbersome and costly provisioning issues. So theirs was a cost issue. Now, we've got a ton of crypto auditor clients that have come on board, particularly in Europe in the past few months, but this is one of the major ones, a major European security depository selected crypto auditor to monitor and control external application developers and administrators working inside their data. So if you go back and look at our network-based controls here, they basically wanted to make sure all these remote administrators at the top, whatever they were doing was being monitored inside their environment, because obviously they're managing and storing a lot of financial information that's really critical and would be a great target for a hacker to compromise. So that's our presentation for the day. If anyone has any questions, we've got some time for some Q&A if you want. If I can't answer any of your questions, I'll pass them off to an SE and they can get back to you. There's the chat function if you go to your GoToMeeting or GoToWebinar control panel. There's the chat function there, and you can ask any questions. If there are no questions, then you can just log off, or if you want to follow up, we'll send you a follow-up email. You can email us back. We will also make our presentation available via PowerPoint if you want to use that in your for your reference or in your company to show the challenges inside your organization. And we will also post a video online so that you can come back and view this if you want or share this with other folks. I don't see any questions here. A few thank yous. So thank you as well, guys, for attending. Give it a few more seconds. Oh, yes, and by the way, we will be at booth 2608 at the RSA conference in 2014 at the show this year. And I think if you want to come visit us too, we'll have some good giveaways. Hoodies I think we're giving away this year, so please do stop by. All right, thank you all very much, and I will now end the webinar and have a great day. Bye.